Okay, let's get into this. For our deep dive today, we're talking about how professional broadcasting basically manages to cheat physics.
It really is like that.
We're looking at high-performance video transport. Specifically, how these huge, uncompressed 4K signals get beamed over, impossible distances using fiber optics.
Right. And a good way to frame this is with a system like the DVIGear DVI-7346 extender.
Exactly.
And, this whole capability is what makes modern live events possible. The industry standard is SDI, serial digital interface, because it's uncompressed, zero latency video.
Which is absolutely critical for live broadcast.
Absolutely. The problem is physics gets in the way. Traditional copper coaxial cable just fails over distance. For high-end 4K, that's 12G-SDI, you might get 100 meters. Maybe.
100 meters is nothing.
It's nothing. So what we're really digging into is how fiber optics just blows that physical limit away.
And that's where this tech gets really interesting. We're looking at a system built for just massive data throughput. These transmitter and receiver sets are rated for up to 11.88 gigabits per second. That's a huge pipe.
A huge pipe. And that's what you need to support 12G-SDI, which means you're getting pure, uncompressed 4K video quality. We're even talking deep 12-bit color.
It's the sheer distance that gets me, though, switching from copper to light.
Well, that's the real game changer. Using just a single strand of single-mode optical fiber, the same stuff used for internet backbones, the standard unit can send that signal up to 6.2 miles.
Wait, hold on. 6.2 miles, that's about 10 kilometers.
10 kilometers. And if that's not enough, there are extended options that can push it out to 25 miles, about 40 kilometers.
So if I send a signal that far, is there any kind of latency penalty? I mean, how do you maintain that zero latency guarantee over that kind of run?
That is the beauty of fiber. Light is just incredibly fast. The mechanism is surprisingly simple, really. The transmitter just converts the electrical SDI signal into light pulses.
Using a specialized laser, I see here.
Yep, a 13 and 10 millimeter DFB laser. And then the receiver at the other end just instantly converts those pulses back to an electrical SDI signal. The whole thing is so fast, there's no perceivable lag.
And all of that happens on just one single optical cable.
One tiny cable.
Okay, but running a single cable for 6 miles, that link is going to cross every type of interference imaginable. Power lines, radio towers, heavy machinery.
Exactly. And that environmental challenge is why this technology is so essential. Fiber is just naturally immune to RFI and EMI.
Right, radio and electromagnetic interference.
You run a copper cable next to a huge generator, your signal is toast. With fiber, that 4K signal runs perfectly clean no matter how noisy the environment is.
And it seems like they've engineered the hardware for it, too. I mean, it's housed in these rugged, compact metal enclosures.
Oh, absolutely.
You've got locking BNC connectors for the SDI, and even the optical connectors have these twist-locking metal covers.
Yeah, to keep dust out. They're built to be deployed in pretty much any climate you can think of. The operational temperature range it's wild. It goes from minus 40 degrees all the way up to 185 degrees Fahrenheit.
Wow. And it's doing all that on what, like 1 watt of power?
1 watt per unit. It's incredibly efficient.
And we can't forget the audio. The amount of audio embedded in the SDI signal itself is huge.
It is. With 12G-SDI, you can support up to 64 channels of embedded audio.
64 channels of 48 kilohertz, 24-bit audio. That's enough for a whole broadcast mixing console, all running down that single fiber strand.
And if we connect this to the bigger picture, you see this kind of high reliability gear and critical infrastructure. We see it in government tenders for things like video conferencing systems.
Right, where the standards are incredibly high.
Extremely high. They'll mandate multi-year on-site warranties and have huge financial penalties, sometimes up to 10% of the equipment cost, if a problem isn't fixed almost immediately. So that signal integrity has to be guaranteed.
So what this really all means for you is that the shift from copper to single-mode fiber isn't just about going farther. It's about guaranteeing that top-tier, uncompressed 4K video quality and a massive amount of audio over city-spanning distances.
And doing it no matter how much electrical interference is around.
Exactly.
So the next time you see a live, crystal-clear 4K broadcast from a stadium or across a huge campus, just remember there's this high-performance gear silently turning electricity into light and back again, making sure that video is perfect, mile after demanding mile.